Hello, welcome to the Intro to Design Reviews. We are thrilled to have you participating. Just to let you know, all of our presentation files will be available on the National Registry in the team workflow under Files Shared with Your Team. And links to the presentation videos will be on the Rocky Mountain Best YouTube channel under one of our playlists. In order to access the National Registry, I want to remind everyone that students need parents to create their account in order to access the team's workflow on the registry. Again, welcome to the Intro to Design Review. We're going to be covering two different design reviews. One is preliminary design review, which we'll talk about in more detail. That is new this year for Best Robotics Teams. And then the critical design review, which was handled a little differently last year, that we're going to talk about also. As an introduction, let's talk about design reviews at a very high level in general. Design reviews are a common part in higher education as well as industry. They're very common in engineering, but in other technical areas as well. And senior projects in engineering colleges also have those commonly. So in a design review in these higher education and industry, what you would experience then would be experienced technical and business leaders, and very often the customer for a particular project would be participating. They would be asking questions about the capabilities, trade-offs that were being made, and design details. And in particular, everyone working there wants to make sure whoever is buying this particular system, that it is being provided with what the customer is wanting. There's queries about materials, staffing, risks are very common, and schedules also very common, as well as cost, which is not something that you're going to be doing, but is also can be a significant factor. And discussing alternatives to mitigate risks, maybe meet schedule, lower costs. So you, by practicing this now, getting the experience, you'll be prepared for a future career, and in engineering in particular, and other careers also. So under BEST, let's talk about that for a minute. It's very different, much smaller scale than what you're to encounter in higher education or industry, but the same kind of topics. These are going to be done online. They're going to be 30-minute sessions, and with experienced volunteers from our group, they'll be working with you to help you improve your design and overall make your team successful. So at a very top level, the preliminary design review is 2 weeks into the 8-week schedule. It's optional. It's highly recommended for brand new schools, maybe schools with a little less experience. And the critical design review is at week 5, and it is required. So unlike the critical design review that we've done previously, this is much more of a mentoring session, and we're going to talk about that more. So let me give you a quick overview of what we're going to be talking about as we go forward. The best PDR and CDR expectations, we'll talk about those in detail. We're going to do a real quick introduction into engineering design process, which is the structure within which PDR and our CDR would occur. I'm going to give you a quick introduction to some design terms and example concepts. Then we're going to talk at a high level about templates, and then quickly review some examples that we're providing to you, and then wrap up with some advice on how you can prepare for this session. Okay, let's talk about expectations and kind of tone of it and what this 30-minute mentoring is looking like. So these sessions, again, is to make sure you're starting out in the right direction, you're kind of focused and making progress. Don't delay because you think you're not ready. Everything doesn't have to be done. We're working with you towards assisting you in moving forward in a good direction. And work in progress and partial information is expected. We're planning to record these online so you can share them with others. They are not scored. We do not have a score sheet. They're not part of the Best Award. There's no trophy. And again, we will give you some sample templates. You can make changes as you see of use to you. So it's supposed to be helping you. The templates do kind of guide you and might be helpful for you to consider all the pieces, but they're not required. So we previously talked about kind of the tone and very high-level expectations, but let's talk about some more specifics. So PDR, again, is at week 2. So what we're looking for kind of at this high level is that you have a plan and you understand the questions that you have. So we're looking at you preparing material that is like 5 to 10 minutes at a very high overview, and then having feedback and discussion. That's kind of a goal that we're looking at. We can be flexible with what works for you. We do have only 30 minutes, trying to do all the many teams. If we encounter something that we need to follow up on, we can look at doing that too. So again, these are draft quality, unlike what we did previously where you were assessed on the quality of your presentation. And one more time, it's a snapshot. So the templates are to guide you on the information that we suggest. And we expect, again, work in progress, partial. So when we talked about the customer in the beginning, in an industry and higher education, in your case, Bess is going to be the customer, and the voice of that customer is the game rules. So your game rules are telling you what your best customer is looking for. And you want to make sure what you're doing is in alignment with those rules. And in many circumstances, the game rules are the requirements, and that is a concept that we're going to talk about more. And again, during this 30 minutes, we're looking at open discussions. We're not looking at quizzing you. We may do some brainstorming. Since this is very early, we're going to encourage you to consider other alternatives, maybe reconsider some things you've already considered. And at this point, your design is definitely not firm. So then a CDR, which is at week 5, and so you should have a design at this point, and it should be before you have finished your robot and considering it done. If you're earlier than that, we can talk to you about trying to schedule earlier in the process, if we can fit that in. Again, looking at you providing an overview and then that feedback and discussion. At this point, we're expecting that you'd have a prototype of some kind, either in drawings or simulations, and that the information compared to what you had on week 2, which some of it overlaps, and at this point it's more mature. And indeed, we're looking at some of this material being transferable into your notebook. And your slides, we're expecting more detail than what we saw at week 2, of course. And we don't want you to read slides. We can kind of look at concepts quickly and try to save time for discussions. And this, for our volunteers, are new for us also, so we'll be all working, trying to make it a benefit to you. So let's get real basic here. We'll start in the lowest level, saying what is design? So design is about creating both a form and a function and achieving with objectives and constraints. We're going to talk about some of these later. As an example of form and function on this page, there's a form of an airplane, a notebook, a pen, and a robot. Each of them have different functions and, again, the forms. So an airplane is getting and moving through the air, but this particular one has additional military functions that you would not find in like a commercial airliner. So the form looks different. They all fly through the air and they have additional functions. This is a really fancy pen that has additional capabilities as compared to a pencil. One example I like to share is NASA spent many dollars in figuring out a zero gravity pen that could be used in space, whereas the story goes that the Russians used a pencil which had the same function working in zero gravity, different forms, but the function is the same. And in that case, your objectives being zero gravity and the constraints being also within zero gravity too. Perhaps a better example for objectives and constraints and that form and function. So you're being asked to produce an engineering notebook. When I first started in BESS, they were all in 3-ring binders. So that function of conveying information about your design process was satisfied in a form of paper, whereas now it's all done electronically. And your objectives were still the same, being able to convey information. Your constraints were a lot different versus the limitations of paper and the limitations of electronic files. And then robots can be all over the place as far as the functions they do, forms they take, and their objectives and constraints. We're going to talk some more about these, but this is an introduction of design can be many different things. So the engineering design process is one of the core foundations of working within BESS to build a robot. We expect everyone to have a process. This is one of many that could be considered. It's an example. You may use this if this is the steps you're taking, or you may have another one that you know of, or you may do some research on it. But this is one that is a valid engineering design process that you might consider using. So of the 5 steps here, and then 6 and 7 with the repeating and then delivery, they build on a base foundation and get to actually have a functioning system. So it highlights in general where in the process with the yellow arrows where a PDR and CDR are expected to occur. So the PDR is really as you're understanding the problem that you're being asked to build a robot to solve is really the focus of that. The rules being the foundation of that best provides you. And this year, I think they're around 30 or 40 pages for the actual game. So it's a significant amount of material. The first thing is to dig into the rules and understand that. And then define from that the requirements, either the ones that are in there or that are ones that you recognize you need to do, see other designs come up and inventory resources. And something that we probably should have highlighted is the strategy. You're being asked to score a lot of points. So which of those points are you looking for? What is your priorities on achieving those? Kind of how are you attacking this game field? And then concept exploration is all about brainstorming. There's a lot of tools associated with that. So considering what you're trying to do strategy-wise, what designs do you look at, and select a design or multiple. And then within those, looking at those designs, you analyze and prototype. You can use cardboard, you can use other materials you might have around, boxes, plastic things. The prototype is whatever it is that can kind of convey what your robot is going to look like. And this area is all about trying things out and failing early and failing often, trying things out and seeing what you can do. Having a mock-up of the game field or an actual game field that someone in your group builds is also very helpful. Within here, tape on the floor, boxes, frameworks that represent the game field is another component of that. And this, again, is you want your critical design review before you're out there actually cutting plywood and cutting PVC and putting things together. So you want to do it with prototypes of where you're at. And looking at building the pieces, we'll talk a little bit more about having a base with your wheels and some kind of manipulator on top of that and seeing how you're going to put that together. And then, of course, you need to put all the pieces together, assemble it, and then test and test and test some more. As you learn when you go through each of these, this is repeating a step. If you try something in a prototype, doesn't work, you may go back brainstorming. You may go looking at the rules again, figuring out those requirements. And at the end, when you're done, hopefully you've done all that testing and you have a product you're ready to go forward with. So in addition to considering the robot kind of that physical pieces that are in your kits that you'll either have or will be receiving today, you also are given software development capabilities, tools to be able to program the robot. And it has a little bit different process that you need to be addressing in your engineering notebook also, of looking at requirements, design. There's no manufacturing, it's more of an implementation, and test also again, and then deployment of the software within onto your robot and managing that. So here you've got an electronic set of files that you're working with. So, however, those files need to accomplish something. They have to have a function that it's doing, and you need to know how you're going to accomplish that. And then looking at with the understanding what it needs to do, talking about the design of it, implementing, actually generating the code in this point. Instead of cutting plywood, you're actually generating code files, with these two steps before being more just capturing the concepts in diagrams and words. So here again, early is you need to be thinking about PDR, what you're going to be doing with the software, what tools you're going to be using, maybe how you're looking at testing, who's doing this, and verifying it. And then a big part of being successful with software is having a process of how you keep track of versions. You have files, you change it, it's another version. Being able to trace this is essential in managing, also making sure it doesn't get deleted, having backups. So it's all about dealing with files and managing it. And then working with the people doing the robot, being able to incorporate that into the robot so you can actually get it to move and do what you want it to do. So let's talk some more about the design foundation, and want to go through some terms and concepts that are used by best and also in industry as well as higher education. So we're going to run through these pretty quickly. They may be foreign to you. Starting getting a handle on these concepts will help you be able to communicate in the PDR and CDR what you're talking about, and having a common language that we can talk about. And want to talk about risk assessment, which is a big part, like we said in the beginning, of what your customer is interested in and that you need to be managing. So I'm going to talk about the concept of a system and components. So your robot, the physical robot as well as the software as well as your driver and spotter are part of your robot system. So that's the very top bucket that you put all the rest of these components within. So I mentioned in general robots have a drive platform. You need to maneuver about the game field. You need to be able to have speed and position control. So these are examples of functions that part of the robot needs to do. And that's, in this concept, a component that goes into this bigger bucket of robot system. Then having some kind of movable arm and perhaps a gripper or a pusher or something is another major part of the physical hardware part of the robot. Moving left and right, up and down, in and out, and gripping. So these are all functions that you could be talking about with us at a PDR and CDR. And then the software component is another critical one that's maybe often overlooked in being able to help you looking at moving your robot very efficiently, quickly, being able to score a lot of points, making it easy or hard for the driver with the joystick. So the software part is programmed onto the Cortex controller. That is the electronics brain that sits on your robot. So it's going to be where you actually take software from a computer and connect to the Cortex, so then the robot has those commands that it can move. And again, looking at programming it for the driver to be able to control all the electronics on your robot, and with the goal being able to score as many points quickly. And then finally, another component of your total system is your driver and spotter roles. So in the rules are constraints associated with those, what they can and cannot do. You have limitations in what the joystick options are. And thinking about what they need to do, how they work, the driver and spotter work together, how that joystick fits in there with the interface to the robot. That's how you're controlling what it's doing through the software on the robot. And thinking about what are your scoring opportunities. There's lots of ways you can score in this game. And are we going to try to do them all? We're going to focus on some. So thinking about helping that driver with that, and overall giving ways for them to score points quickly. Okay, let's talk about some requirements and some examples. So what is a requirement? It's a statement that specifies something that the system, your robot, must do in order for you to work, satisfy what the customer wants. In this game, customer wants certain points scored. So how can you do that? And what are these statements of what your system, your robot, your software, your driver, your spotter, all those components need to do? And so it talks about requirements, specifies. These are kind of general kinds of things here. But it's, when you look at the rules, some examples, the game field has certain sizes, probably constraints perhaps that the robot needs to move through, things that it needs to interact with. So it's, what does that game field look like? There's a set of requirements there associated with scoring points. So there's two kinds of requirements that you'll see in perhaps the engineering notebooks that you're being asked to write. There's stated ones, which is basically the rules document, and we talk about functions and non-functions, so being able to interact with the field and how quickly you do something. You've got 3 minutes to be able to score as much as you can do, and the performance non-functional ones have some things that don't work directly, except for there is a max weight that's in the rules. So those are things that your customer through the rules are telling you what to do. And then you, as the developer doing this design, may have some additional requirements that you need to do that the rules document doesn't tell you need to do, but because of the strategy you have, it's things that you would need to do. So an example would be perhaps derived is you would say, we're not going to do everything in the rules document, we're going to focus on a subset of the scoring. So you would say, these are my priorities, which isn't given in the rules document, and how you want to go attacking that. And maybe there's a certain way you want to interact with a game field piece, so that you would need to include that for your robot to be able to do it. And then talking about there's requirements. If you say, I want my robot to be able to do certain functions, certain speed, certain priorities, you need to then, if you say it needs to do that and then you build it, then you need to verify that it does and validate it's doing it right, the right way. So a little bit more background as far as design. You've got requirements that you know from the rules that you need to do, but then you need to say, is the software on the robot going to handle that? Is the hardware in the robot, or is there the driver or the spotter going to be able to accomplish that? And they all need to play together, and you need to make sure, if you've decided this is something your robot needs to do, you need to say, where am I going to allocate, assign that capability that it can do? Is it going to be done in software, hardware, or your driver spotter? So again, we're talking about the components of your system. If you need to move around the system, that's probably going to be the drive portion with the wheels and the motors. So if you say you need to move around the system, go forward, backwards, then you would allocate that to the wheels and the motors on the system. If you want to be able to vary the speed, perhaps that is a software piece. And if you want your driver to be able to control that, then that's part of that human factors. So some requirements is maneuvering in a tight space of a certain width, height, and depth. Then you need to allocate those to those particular sections. And here's some examples of how that requirement could then be allocated down to the driver. Maybe it's training there to be able to move through there. Practice probably too. Software, maybe you need it so that the driver can slow down at certain tight areas pretty easily to be able to maneuver. So perhaps programming through the joystick to give that option. And then perhaps one of the capabilities you have in hardware is having sensors. So it could sense that it's getting close to something and automatically slow down or stop the robot. So these are ways that maneuvering the robot in a tight space may be spread across those three components. The final background piece that we're going to be talking about is risk assessment. And again, another step-by-step process with steps in the design process. Here you're talking about risks. And if you understand what risks are, is what can go wrong with your hardware, your software, your deliverables. A favorite one, a thing that can go wrong is your wheels cannot have traction and you're not able to move around the carpet on the game floor. So that's an example of something that can go wrong. Another one that we're going to talk about in a specific example is what may keep your project, the people working on it, from performing well. You've got a 8-week schedule that you're facing. You've got a certain number of students on your team with certain capabilities, and we're going to talk about that more as the example. So what's the consequences of something going wrong? So using the wheel example of not getting traction, so you're not able to, the risk is your wheels spin without moving. And so that would be a friction component. Your wheels don't have enough friction. What's the impact if it occurs? You don't move, which is not good if you need to move to get score points. And how likely is it to occur? Well, depending on maybe your expertise, the capabilities of tools you have, that may vary. And then you should consider something that's a low risk. Maybe you don't spend a lot of time improving your response to reducing the risk. But if it's a high risk, then certainly something you would need to do. So under the improvement, you need to monitor and review as you go through your 8 weeks of, if you've understood certain risks, how are you doing in reducing that risk? So how can you make it less likely? What can you do if it happens? Or is some more likely or less over time? And kind of what are the things that you and your team can do to reduce the probability that that thing that went wrong or that wasn't performing ideally would be reduced, mitigated. All right, as we're kind of getting to the end here, this is an example of a risk. It's more of the team not functioning, your team of students not functioning the most effectively. So we've talked about having a process. We've talked about understanding what the rules are. Well, if you decide to build without following that design process of understanding what you're trying to do, considering all aspects of what you can implement and brainstorming solutions. And if you decide you're not going to look at the game field distance requirements, so how tall something is, how far from the front of something is, if you decide you're not going to look at that, consider those, which I recommend you do. Your team can find out after you get your robot built that the robot can't score because you missed something. Maybe your robot is too big, maybe its arm isn't long enough, maybe, in particular from the game field, you don't understand how to interact with the pieces. You're going to have to face, with only 2 weeks left, needing to make major robot changes with very little time. And if you're ignoring the game field distances, dimensions, that risk is pretty high. So how do you avoid having that happen? Well, obviously you need to look at the game field drawings as you consider how big things are, how far away. You need to have those understood and identify those as requirements. We talked about having a mock-up of the scoring areas of the game field, either with tape or cardboard or pieces of spare wood, or actually build a game field. You need to create that prototype before you start cutting wood. If you cut wood and you haven't considered the size of the field, you can be faced with having to purchase additional materials beyond what we gave you in your kit. And so if you can do it with cardboard, a prototype, even paper, or things hanging around, kind of considering how does your arm look, how big is your platform, consider all those things, prototype that before you get in there cutting. And continuing to test the robot. If you know that it has to be less than a certain weight as you're putting pieces together, get a scale and weigh it, considering those. And then include considering the risks you've identified as part of a weekly meeting, so you don't forget that you needed to make sure you understood the game field distance. Have you taken that into account? So this is one example of the team not working functionally well. Not so much the example of the wheel spinning, of that going wrong, but this is more following processes. As an example. So the last two slides, I'm going to have a slide on PDR based on the template. What is the kind of information you should be presenting at that PDR at 2 weeks? So this slide has 7 components. I'm going to talk about those very briefly. So having in the template that we're going to be showing in a minute, having a title slide. At PDR, we want you to think about who's doing what within your team. What is the organization? How are you working together? What are the assignments of the individuals on your team? In order to function together, working to produce something, a critical component is those assignments and how they work together. Then a schedule. 8 weeks is going to go by really quickly. You need that PDR at about 2 weeks, CDR at 5. You've got a practice day in there. You've got to get engineering notebooks created at week 6. And how are you going to lay all that out? Have a general idea of what you're going to have done when. And then talking about requirements, one way to divide those up is into objectives. So what's your scoring strategy? What are your constraints? Things like the size of the game field, the rules that tell you about the size of your robot, just in general, independent of the game field, and how heavy it can be. You've got schedule constraints. And then the functions, what does this robot need to do to be able to execute your strategy? So a function would be move around the field, pick something up, touch something, move something. Those are functions that you need, or requirements that in order to score. And then in more specifically requirements as far as sizes of components on the field, kind of a mix between constraints and requirements, and they all play together to describe what your robot needs to do, and then for you to look at and say, have I achieved that when I build it? So this is a very early look at PDR, and then you'll be refining those and improving those as you go forward. And then in the number 5 is where you start talking about hardware, software, and human interfaces, where we talked about drivers and spotters, the software through the joystick talking to your robot, and then the actual physical wood, pipes, electronics also. So at week 2, you're thinking about what are the tools you're using, especially in software. You've got at least three options for programming, having an understanding of what you're going to do there, and make sure you've got the training to use it successfully. At this point, you may be doing some brainstorming based on the requirements that you did in number 4 of what the robot looks like, what your driver control options are, the drivers and spotters responsibilities, and talk about that software version control, the files that you're going to be working with. How are you going to keep track of versions? Where are you going to store it? Where are you going to have that very, very important backup copy of each of your versions so that it doesn't get overwritten? Don't know how many times teams have had a computer fail, have someone wipe something out. You need to have a way to back that up. And then talk about risks. Think about the things you're not sure of and how you're going to keep you from doing something wrong, keep you working efficiently like we talked about in that example. Have opportunity to talk about that and track that. And then we didn't talk explicitly, but on keeping from having bad things happen, you can also look at what's some ways to have some good things happen. We have some examples in the templates that I'm going to show you that you might consider. An opportunity maybe is to get someone on your team who is really good at writing. Let's say you need to produce an engineering notebook. If everybody's there wanting to do the hardware and you don't have someone that can capture the material for your notebook, you don't have somebody that software, you need perhaps there's some opportunities to get some additional skills or get some additional training, opportunities that kind of stretch from what you have as a baseline. So CDR, the template suggests you still have that title slide. Go back and talk some more to us about what are you looking at, objectives, constraints, functions, and requirements. What are the updates there of those requirements? And the robot, talk about each then of the designs in more specific detail of what your hardware is that you're looking at. Don't expect to have it built, but maybe you have CAD or drawings in detail of what you've decided to do. Talk about perhaps prototype photos of your prototype that you've put together, why you think it's good. Talk about how you're going to test to make sure it can do what it needs to do, or how you've already done some tests of how what you need to do. And then number 4, similarly in software, talk about the functions, talk about testing, talk about that version control, how is that working for you, the human interface, the driver, the spotters again. And see where you're at in your risks. Have risks changed? Have you accomplished some things so that they're no longer a risk, so you've dropped them? Anything new? What you're looking at, and again, opportunities. So that's kind of the core. It's another more detailed view of the progress you've made in talking with us. And again, the CDR is required and the PDR is optional. So we're going to go very quickly through the design review templates, the 2 different kinds, using the last couple of charts in more detail, giving you some examples of contents within there also. Again, these are examples. You can choose your own. We created a separate file that has the templates within it, so it doesn't have all the introductory materials, so it's available at this link. So let's go through this quickly. Title page, not much. It's up to you to decide how you want to do it. This gives you some ideas of how to make it fun. So this is an example of an org chart and some responsibilities. We talked about assignments. So this is a very big team with doing Best Award. Best Award with the exhibit booth. The marketing is optional for teams, but this talks about seeing it. You want to look at having responsibilities for hardware, software, notebooks, And perhaps if you need to be raising some money to do some of the things you want to do, if you're best award with exhibits or some other capabilities, having someone there for that too. So the schedule can be just a to-do list. You can put it on a calendar. You can have a mix of the two. Kind of what is, are you going to try to accomplish at what kind of dates? And the list on the left is more of that to-do list with the calendar on the right. What works for you? So this one is talking about those requirements and considering perhaps combining this with some brainstorming as part of PDR. So we talked about objectives, constraints, functions, and requirements. And here's some more examples that you can consider. This was talking about hardware, software, and we really should talk about human factors in here too. About that spotter and driver, their roles. But here's a whole variety of lists of things that you can be considered talking about. Again, these are just some samples, some suggestions. Don't have to talk about any of these. What makes sense for you as you're considering making your robot? So this risk assessment, these are just examples. Figure out what makes sense for you. It talks about physical things on your robot with an eye or sensor. Talks a little bit about software. Talks about more of those organizational things as far as not having the right people or enough people. Again, it's very top level, what makes sense. That you're worried about things that may go wrong or not working efficiently. So this concept is kind of how can you make things, good things happen instead of stopping bad things from happening. And improvements that you can do, maybe ways to score more points. So these are some examples and opportunity and benefits. So what makes sense for you that you want to do as far as making good things happen? Again, we're now in the CDR, the required part. This is a sample of what a title page could look like. These graphics on here are strictly examples. Think about how you want to talk about your robot. And this again is more mature. Some examples in blue text. The table here, there's tons of ways you can attack this and present information. It is really helpful to have things graphically in tables because picture is worth 1,000 words. Whatever you can do, tables, lists, bullets, having paragraphs is not something that's going to be, you'll be able to quickly convey information. Again, you only have maybe 5, 10, maybe 15 minutes to talk with us. Here's another page you can look at, consider. Again, the example of showing tables and what your decision making is. Great way to do it. Having pictures of your prototype, another great way. So just to repeat one more time, maybe more. This is up to you. How can you convey the information? To make sure you're, as you're just about to start cutting wood and putting software onto your robot, what do you want to talk to us about to make sure you're headed in the right direction? Another way to talk about your hardware, CADs, prototypes, lots of ways to capture. So software status similar to the hardware. Give us a snapshot of where you're at. This has code and and perhaps simulations that they're doing. In the yellow, you don't have to have code at this point. You can have more logical flows, functions, capabilities. Is another way to capture it. Just because they're on this chart doesn't mean that makes sense for you. But there's some questions up there, some suggestions. Again, it's up to you to decide what you want to do and the best way to do it. And that really important human interface as well. Don't forget your driver and spotter. What are you doing with training? How can you make it easier for the driver? How can you practice? Again, we're looking at an update to risks. Talk about what you're concerned about now. And here are some examples. Again, make it your own. And make sure you've got actions to be able to reduce your risks. And the final template of opportunities, again, this is just an update. How do you make good? So the last couple of charts, how do you get the most from this? So break the work up. Not one person doesn't have to do all of it. Do a little bit each week, so you're not. You can get the most out of it. This feedback is for you. How can we help make you successful? And I do have listed, as far as robot design, 2 helpful best documents, which are coming up. Again, don't procrastinate, keep up, have a plan, have a schedule, have people assigned, and fill in what you can as you're going away. And if it's not complete, just capture a snapshot. Like we said, it doesn't have to be, you have all the answers, you can come talk with us about questions. But make sure you've got something that you can share with us so that we can give you some guidance. And suggest you have multiple presenters, so someone that's going to talk about us. Make sure you understand who's doing what. And this one of the advice was on a schedule, looking at a Gantt chart. If that's not something you're familiar with, maybe something you want to look into and help keep you on track. Finally, here's some reference material to help you. Very detailed engineering design process, quite a few chart slides within this. Is the understanding and applying the engineering design process. It has a bunch of tools you can use to help you with brainstorming, help you identify and organize and think about functions and requirements. It's, again, very detailed. The next one is a really high-level 5-page summary, real quick to do. If you're new to it, a great way to start. I highly recommend taking a look at those 5 pages and see how you can apply what is in there. Some great charts to help you convey what you're doing. Well, final chart. Reminder again, National Registry Team Workflow. This material will be shared there, or the videos on the Rocky Mountain Best YouTube channel under the playlist for 2023. And in order to get access to all of this gold mine of information on the registry, your parents need to create an account so that you can access it. Thank you.